My name is Niclas. I work as a machine learning engineer at Tenfifty, and I'm gonna talk to you before you get some sparkling outside. I'm excited for sparkling as well. I work for Tenfifty. We are a small Gothenburg-based company. We work to help our customers solve their problems using machine learning, AI, crawling, and optimizing their workflow and solve their problem in-house. And I'm gonna speak to you again today about one of those projects we did in collaboration with the Swedish Maritime Administration. This is a beautiful but kind of blurry image of the Swedish coastline. As you all know, the Swedish coast is amazing, but sometimes things go wrong. Therefore, the Swedish Maritime Administration has their Joint Rescue Co-ordination Centre here in Gothenburg. They handle to respond to and manage all the emergencies in Swedish waters, the biggest lakes, and the airspace above Sweden. And they handle roughly 1,200 emergencies each year. There are 16 international ways to get help or to signal that you are in an emergency. But for this speech, I'm going to focus on this one. The VHF Radio and the Mayday call. You all know it. You have heard it on radio or on TV or news channels. But the problem with VHF Radio is that by law, Swedish Maritime Association needs to monitor this around the clock. And this job is performed here in Gothenburg by one operator. This operator have their monitoring station where they're surrounded by a lot of speakers. Those speakers are representative for a number of receivers around the Swedish coastline, and each speaker is about 4 receivers or towers. But this is a lot of work, and there are 5 main problems for the operators. Firstly, as the Swedish coastline is so large, there could be people talking in different parts of Sweden. They can't hear each other, but the operator gets both sources at the same time. So it's difficult to hear what's said in different places. There also, the channel 16 that's used for emergencies is not just used for emergencies. It's also a lot of other talk. They're talking to each other, they're talking between coast guards, between pilots, and so on. There are also a lot of messages. They will talk about between 2 and 3 million messages each year just in Sweden alone. And besides the task of monitoring, the operators does a lot of other work. For example, handle if something happens, to respond to it. They're also monitoring ice activities for the winter and other tasks they have. And the final problem, for everyone have heard and VHF transmission, they are very noisy. There is not easy to hear and they are very unclear. So about 12 years ago, one of the operators in Gothenburg got the idea to get some kind of computer aid to help him in this. But as we all know, 12 years ago, the iPhone was 3 years old, I think. Speech text wasn't up to this task. But about 2 years ago, we started the innovation project Heimdall. Project Heimdall set out to create and develop a functional AI that could support the interception and interpretation of these incoming messages and to notify the operator on how to handle them. So we want to start off this project when we started to get a baseline. What does the industry leaders think or solve this problem? So we started with this title. You may wonder, why is the Oompa Loompa? The answer is, when we tried one of the most common APIs for this, this is a conversation between the vessel Isabel and the Stockholm pilot station. But this speech-to-text model returned, Isabel, Isabel, Oompa Loompa. This answer may not seem as interesting, but it is really, really interesting. And I'm a bit gonna touch on what Stefan talked about before. We have this other example where we have a security message. It's an informational message sent out to all ships informing of bad weather, aground, something happening, and so on. As you can see here, this STT model, instead of saying security, starts talking about the TSA Cupra, maybe a nice car, but it's not really what we want. And we also have where we talk about Sweden traffic, a name of an organization. We get Sweden traffic. We got a hypothesis. One of two problems resulted in this. The first one is the noise. We started with a clean sample that the STT models went perfectly on, and we started to increase the noise. And we realized that we could have a 2 in signal-to-noise range on the noise before the model started to miss words. So it needs to be something else. The something else is that these models is trained on a specific type of datasets. Some of the most common is we have audiobooks. They are trained on a dataset with conversations in the European Parliament that is transcribed by users, and this kind of ordinary conversation. But we don't have ordinary conversations here. We have specialized, domain-specific conversation. So we need something more custom. We started out by looking at what data was available. For this project, we got a bucket of 2.7 million recordings. That may seem like a lot, but as we also have talked about today, data amount, quality over quantity. We need qualitative data. And the problem with this data is around the Baltic regions, there are a lot of countries. We have data in more than 7 languages spoken. We also have many audio files with static files, or static noise, just no talking at all. And we have an overall high noise floor. The final problem is that this data is unlabeled. We have no labeling for this. So we start there. We started to label this data. Transcribing audio file takes time. And it takes even more time when you have a specific domain that we need experts to transcribe. We all tried as a company to transcribe this. It's not easy. We needed those who work with this every day to help us. But they have other tasks. They don't have a lot of time. And even they don't guarantee perfection. So we need something that can handle untranscribed data, a lot of it. We also need to minimize the amount of transcriptions required, and we also need, as talked about before, to minimize the computational requirements. And the solutions, as you can see, is self-supervised and transfer learning. So if we put all this together, we want to start with a pre-trained model. We want to train some more on the domain-specific unlabeled data, and then fine-tune it on labeled transcribed data. And the model fitting this is VHF 2.0. VHF was a model released by Facebook in 2020. It has 2 versions, one with 95 and one with 317 million parameters, and is made up of a convolutional feature encoder and a huge transform block. But this is not the architecture that is interesting, it's how it's trained. VHF is trained in 2 steps. First, a pre-training step, where we just learn discrete speech representations. It could be sounds, phonemes, parts of words, and then we add some neural networks, linear neural networks, to fine-tune this using CTC to turn those outputs with label data into a final word or a transcription. But there's a part missing here. VHF also has a huge open source community. This is Hugging Face. For those who don't know, Hugging Face is a huge platform for sharing pre-trained models in language and main language, but other models as well. And this is a search for VHF here, where are 2,060 available results, models pre-trained by others available for use for free. And this is important because as Facebook, their large model, was trained on 128 NVIDIA V100 GPUs for 2 weeks. That's a lot of computational power to train this from scratch. So we started out with their pre-training, added our pre-training, and finally fine-tuned on our data. So how do we compare? For the first example, as you can see, we don't have the Oompa Loompa, but I also talked about the transcription. The data quality is not perfect. As you can see here in the transcribed, even the transcriber, the person working with this every day don't know what was said of the pilot. But we get the main parts. We miss the name of the vessel, but we get the main part. If you look at this more common message, we got an almost perfect match with just one word being wrong. So this is a much more useful for the task. If you talk some numbers instead, if you look at the English, we are less than half the errors compared to the standard solutions for speech to text, with very simple and low-cost training on these open source startup points. And we outperformed with a great margin. But you can also talk about the numbers and theory. But the best part, I read somewhere that about 70 or 80% of all AI projects in the world fail and never reach production. This project is running right now. We deployed a solution where we look at the raw streamed audio files, not files, but audio stream that the operator gets, and uses an on-site deployment because of security reasons to be able to transcribe in real time and to use that transcription to classify what is said and to notify the operator if we find something interesting. And this is already proven useful as it have already picked up things that the operator missed due to other tasks they had to fulfill. And that was everything I had. If there's any questions, please follow. And I was also told by our CEO that I need to say that we are hiring. If you think this kind of work is interesting, we are not just working with speech to text. We're working with all kinds of modeling for companies and customers. Thank you.
Thank you. Very interesting and very timely as well. Good. Yeah, I really like that quote. The best AI projects are the ones who's finalized. Yeah, that's a good one. All right. Are there questions?
No?
Yeah, we have one here.
Every time you say no, someone is like, yes.
Hi, thank you for the talk. I have a question. Will you be releasing your trained model on Hugging Face, for example?
It's a bit unclear, as we are constrained by a lot of privacy and regulation here, both security and privacy. So I don't think so, unfortunately.
Great. Do we have more questions? Yes.
I have one question regarding the accent of the same language. How did you deal with it?
Right now, we have models for Swedish and English, and there are 2 separate models. We split the data, we sorted the raw data, and we split the transcriptions into 2 models that work simultaneously. And we then try to filter out which transcription is, which text is makes the most sense, and try to use that for the final classification for the finding. And as we talk about just accents in the same language, we train a diverse data set with a lot of different. The shipping industry is widely diverse, and it could be a vessel registered in Cuba containing crew from 4, 5, 6 different countries. So we have a lot of different accents in the data set already.
Hi, thanks for your talk. I'm interested in how you make the best use of your domain experts, so your operators. So in the tool that this is being presented to them in, is there a mechanism for feedback there in terms of the data? And then also, how will they set up these rules or alerts that they're going to be interacting with?
Right here, maybe you can use the laser. Right here, inside this, when they can open up this card to get the full transcription, they also, as you said, they can report if we missed something. They can also classify these ones we have triggered if they are correct or not, to get feedback back to us so we can improve and retrain and improve the classification and transcription models.
Great, thank you. Yes, we do have one more there. I'm just running in circles here.
So do you get the users engaged in that annotation? Yeah, good.
We get both feedback directly and through the tool.
Oh, perfect.
Hi, thank you for the presentation. During the COVID period, for example, I think there were some reports that several speech systems had some kind of, let's say, less accuracy because people were wearing face masks. Did you notice something like that, or did you intentionally train for those kind of data, I mean, whereby people wear face masks?
No, not specifically face mask. The data we have is noisy and mumbly at best. We have a lot of static from the transmissions, and they usually don't wear masks on the ships. Okay. So we didn't take this specifically into consideration.
Okay, thank you.
Right, there was one more.
Hi, just one final thing. We are hiring, not firing. I will say that. Everyone know that.
Okay.
That's my boss.
It was. All right.
Good. Yes, no more questions on the other side.
Last chance. No. So thank you. Very, very nice project, presentation, and great questions. Yeah.
Thank you.
Thank you.